Hello everyone, and in today's video we have got a question on sectors and segments, so a chapter 5 question. These kind of questions in the exam tend to come sort of like mid-paper, and they're usually worth around 5 or 6 marks, and to be fair they're usually quite a nice question. So this question 6 that we're about to go through is a pretty typical kind of question of its type. So it says the shape, all those letters is shown in figure 1, is the design of a logo. In the design, OAB is the sector of a circle with center O and radius R. The sector OFE is congruent to the sector OAB. ODC is the sector of a circle with center O and radius 2R. And AOF is a straight line. Given that the size of the angle COD is theta radians, write down in terms of theta the size of the angle AOB. Okay, so what angle are we talking about when we talk about angle AOB? Let's have a quick look. So if we annotate on the sketch here, angle AOB is this angle here. Okay, so that's our angle AOB. So what do we know? Well, we know that a straight line is pi radians, and these little sectors here are congruent to each other. So we can say that we've got pi minus theta divided by 2. So pi minus theta divided by 2 is going to give us the angle AOB. And that's our part A done there for 1 mark, because a straight line is theta radians. Okay, part B, let's have a look at part B. It says, show that the area of the logo is given by that expression there. So first of all, let's find the area of the sector COD. So if we write down COD. Now, the area of COD is going to be, the general formula is area is equal to half r squared theta. So that's our general formula. So what we're going to have here is we've got a half, and our radius is 2r, so 2r squared, times by the angle, which is theta. So that area is a half times by 4r squared theta. So that area is going to be 2r squared theta. Perfect. Now let's have a look at the little ones. So we've got 2 of these little sectors. Okay, and the 2 little sectors are ABO, and we've got another one, EFO. And let's think about the areas of these. So again, our formula is area is a half r squared theta. So this time, what have we got here now? We have got a half times by the radius is r, half times r squared, and our theta this time is our pi minus theta over 2. So let's see what that gives us. This is the area for one of them. So we're going to have a quarter, because we're going to have a half times a half, and we're going to have r squared times by pi minus theta. So that's our area for one of those, but we've got 2 of them, so we need to double it because we have 2 of them. And so therefore that gives us an area of a half r squared pi minus theta. So we can bring these 2 results together now, this one and this one, to find our total area. Okay, so when we add those 2 results together, we're going to have our total area is going to equal the 2r squared theta that we found, and then we're going to add onto that the half r squared pi minus theta, like so. Perfect. So we can add those together, and let's see what this gives us now. Now, what we can do here is we need to get out a common factor of a half, okay? So I'm going to reimagine this as 4 over 2. So I'm going to think of that as a half times by 4 r squared theta. And I've engineered that in such a way so that we've got a common factor of a half here. Okay, and now let's take out our half r squared. So half r squared comes out, leaving us here with 4 theta. And then what have we got? We've got 4 theta there, half r squared comes out, and that just leaves us with pi minus theta. And then when we collect like terms, we have a half r squared 3 theta plus pi as required. Let's write down as required. There we go. So that is our part B done, which was nice. Only 2 marks, but I really do think these questions are quite a nice gift, usually, of some nice kind of free marks, if you will. So that's fine. So let's just erase the little annotations there. Perfect. Now, almost done. Part C, find the perimeter of the logo, giving your answer in its simplest forms in terms of r, theta, and pi. So in order to find that, we're going to need to know the arc lengths, okay? So let's envision over here. Let's first of all find the arc length CD, this arc length here. Now, arc length is L is equal to r theta. That's our general formula, okay, for an arc length. So we've got here our angle is theta, and actually our radius is 2r. So that arc length CD is equal to r, which is in this case 2r, times by the angle, which is theta. So that is our CD. Now we need to find our little AB and our what we call EF. So we've got AB and EF. Let's find those. So AB and EF. Now this is going to be, again, if I write down AB is equal to r theta. The radius is r, and the theta, you might remember from before, the angle was pi minus theta over 2. There we go. So that's AB. Now we've got to also add on to this EF. Okay, so AB plus EF means we're going to have 2 lots of those. So that is going to be r, open brackets, pi minus theta. So that expression, r, pi minus theta, that is our arc length AB and our arc length EF. So we can add everything together now, because what have we got? If we look at our logo, we've got an R from A to O, an R from O to F. We've got another R from E to D, and we've got another R from B to C. So the total perimeter is going to be given by 2 lots of R along the bottom. We've got another R from C to B. We've got another R from E to D. We've got this expression here, our R pi minus theta. And we've also got another arc length, which was our 2r theta as well, from the length of CD. So we just need to collect like terms, see what we get here. So this is giving us 4r, so 4r, because that one and that one and that one is 4r, plus r times pi, minus r theta, plus 2r theta. So let's see what happens with this. We continue collecting these like terms. So we've got up to here. We continue collecting them, and we've now got 4r plus r times pi. And then we've got 2r theta. Take away r theta is going to be plus r theta. And then we can take out now a factor of r from this. And we take out an r, and we're left with 4, add pi, add theta. And that is the answer to that one. So I hope you found that helpful. That's pretty standard kind of question. As I say, you know, it's a really nice kind of question when these come up. And just as long as you remember those 2 formulae, the L is equal to r theta, and the fact that area is equal to a half r squared theta. If you remember those 2 formulae, you know, then you're off to a good start, and they're usually quite nice questions. I hope you found that helpful, and I will see you in the next video.